Hello students, through this presentation we will learn Newton's first law of motion, which is also called as law of inertia. Now we will see what is a force. Force is an external effort which may move a body at rest or stop a moving body or change the speed of a moving body or change the shape and size of a body. There are two types of forces. First is contact forces and another is non-contact forces. First we will see what are the contact forces. Contact forces are forces which act only when objects are in physical contact with each other. Now in contact forces, these are the forces that are coming. First is the frictional force. Friction is the force that opposes the motion of an object. It always acts in the opposite direction to the attempted motion. Its size depends on how rough the surface is and on the weight pushing down on the surface. Now then comes the normal reaction force. The normal force is a force perpendicular to the surface on which the object is laying. It is what keeps the object from falling through the surface. Then it is the tension force. Tension is a strain force that is exerted by a stretched spring, rope or a string. At each end, the tension force acts in the opposite direction to the pulling force. Now is the force exerted during collision. In a collision, a force acts upon an object for a given amount of time to change the object's velocity, and next is the force applies as push or a pull. All forces are either push or pull. When force move object away from something, that is push, and when force brings an object closer, that is pull. In this way we have seen the contact forces. Now we will see what are the non-contact forces. The forces which do not involve physical contact between the surface are called as a non-contact forces. Now in non-contact forces there are the gravitational force, electrostatic force and magnetic force. Now we'll see what is the gravitational force. Gravitational force is the force of attraction between all masses in the universe, especially the attraction of the earth mass for the bodies near its surface. Now there is the electrostatic force. Electrostatic force is the force of attraction between unlike charges or the force of repulsion between the like charges. Now there is a magnetic force. Magnetic forces are the forces due to the magnetic field of a magnet. It is an attractive or repulsive force exerted on a magnetic pole or a moving electric charge in a magnetic field. Now we'll see effects of force. First is force can move a body at rest. As you can see here, this boy is trying to move this heavy load by applying force, and in this second image this man is applying force so that car will get pushed in required direction and it will help that car to start. Now the next is force can stop a moving body. If you will see in this case, to catch a ball, the fielder has to stop the ball. This means force is applied against the motion of the ball. Then force can change the speed of a moving body. If the force is applied in the direction of motion of the object, then definitely its speed increases, and if the force is applied in the opposite direction of a motion of an object, then speed decreases. Force can change the direction of a moving body. Now here this cricket player is hitting this moving ball in such a way that it will change its direction. And now in this case, this player is hitting this coming ball with this hockey stick in such a way that it will change its direction. Now next is force can change the shape and size of a body. Now you can see here in this picture, due to the applied force, the shape and size of this spring has totally changed. And now in this case you can see the condition of this can due to the applied force. So what is the meaning of that? The force may cause a change in the internal arrangement of molecules making up the object, and depending upon the magnitude of the force, the size and the shape of the object may change. Now we will see what are the balance forces. If two forces act on a body in opposite direction and if both the forces are equal, then the resultant force acting on the body is zero. Such forces are called as balance forces. Balance forces cannot change the state of rest or the motion of a body. Now if you will observe on this object, 8 Newton force is applied in this direction and 8 Newton force is applied in this direction. As the same amount of force is applied in the opposite direction, the net force acting on this object will be zero and it will not produce any change in its state of rest or the motion of a body. Means if the body is at rest, it will be at rest, and if it is moving with some constant speed, then after the application of these forces which are equal in magnitude and opposite in direction, that object will move with the same speed only. Unbalanced forces. If the forces act on a body in opposite direction and if one force is greater than the other, then the resultant force is not equal to zero. Such forces are called as unbalanced forces. Now if you will observe here, 4 Newton force is applied in this direction and 7 Newton force is applied in this direction. This force is stronger as compared to this force, and these forces are acting in opposite direction. Hence 7 Newton minus 4 Newton, that is equal to 3 Newton force will apply on this object, and this object will move in this direction, which is the direction of the stronger force. Now in this case, 5 Newton force is applied in this direction and 5 Newton force is applied in the same direction. As these two forces are acting on this body in the same direction, hence they will get added. That means 5 Newton plus 5 Newton means 10 Newton force will applied on this object in this direction. We will see the concept of balance and unbalanced forces through this simple simulation. As you can see here, there is a rope on both sides with 4 knots that represent 4 different positions for people to grab onto the rope. You also see a series of men down below, small all the way up to the large, representing small to large force capabilities. So let's start with the basic situation. We will put the person of equal strength on either side of the rope. As force is a vector quantity, hence there is a right force in this right direction for this person and there is a left force in left direction for this person. If you will replace this person with this person who is having more strength, then this arrow gets larger. It means that at this stage more force is exerted in left direction. Now we will go back to our original situation and we will see what happens here. When I click go, if we have equal people on either side of the rope, both exerting the same force, and when I click go, both are pulling and nothing is happening. We say in this situation the forces are balanced. The left force is exactly equal to the right force.
Now because forces are vector, hence I would also say that the right force is positive and the left force is negative. And when I add up these two forces, I get a sum of 0. So the sum of forces is equal to 0, and in that case we see that the object doesn't move. Now let's pause again and let's add another person on this right side, person with a less strength. Now right away we see that the right force is now a little bit bigger, and of course now the sum of the forces is to the right. A tiny arrow to the right shows that more force is getting exerted in right direction. If we click on the value box, then we see that the right force adds up to 150 Newton and the left force is 100 Newton. Clearly, if right force is 150 Newton, then we can say that this big person is exerting 100 Newton force. So our sum ends up becoming 50 Newton. As 150 Newton minus 100 Newton is equal to 50 Newtons. We call this value as a net force. So in this case, we have a net force to the right. Hence, the object will accelerate towards the right. So now let's summarize. If you have an unbalanced force, meaning the sum of the forces is anything but 0, the object will accelerate in that direction. And if the forces are balanced, then the object will not move in any direction. We have seen this scenario. See here. Here, when we are clicking on the go, and as the strength at both of the direction is same, so they are not moving in any direction. So in this way, we have seen the concept of balanced and unbalanced forces.
Sir Isaac Newton first presented his 3 laws of motion in the year 1686. His first law states that an object continues to remain at rest or in a state of uniform motion along a straight line unless an external unbalanced force acts on it. Now we'll see what is inertia. The natural tendency of objects to remain in a state of rest or a uniform motion is called as inertia. That is why the first law of motion is also known as the law of inertia. This card and coin experiment is a very old and widely used experiment to show the property of inertia. What we have to do here, we have to fill a glass with sand or water, and on this glass we have to keep a piece of cardboard, and over this cardboard we have to keep a 5 rupee coin. Now we have to strike this cardboard hard using our fingers, and afterwards we have to observe what is happening. Though the cardboard is flicked, the coin on that cardboard tries to keep its state of rest due to inertia, but afterwards it falls into the glass due to gravity. Now we will see examples based on the principle of Newton's first law of motion, or we can say law of inertia. Now here this car is moving with a speed of 80 km per hour. When it was suddenly stopped by the brick wall, what's happening? That person is being ejected from the vehicle at the event of the crash. Why this is happening? Because when the car was moving with a speed of 80 km per hour, the person who is sitting in this car is also moving with the speed of 80 km per hour. But when it was suddenly stopped by applying the brake, that vehicle has stopped. But the person who is sitting in the car is in the motion due to the inertia, and because of that he is ejected from the vehicle. Don't let this be happen with you. Always wear seat belts, because seat belts make the stop less abrupt and reduces the risk of injury. Hence, from this we can definitely say that Seat belts are lifesavers. Now here is a question for you. Here this is an empty bucket and this bucket is filled with sand. Now the question is, the bucket filled with the sand is more difficult to be pushed. Why? What is the relationship between mass and inertia? So what's the answer for this? Let me tell you. When both the buckets are pushed, it is found that empty bucket is easier to push as compared to the bucket with the sand. When both the buckets are oscillating and an attempt is made to stop them, the bucket filled with sand is more difficult to stop. This shows that mass is a measure of inertia. An object with a larger mass has more inertia. An object with a less mass has less inertia. Changing the motion of an object which has less mass is easier than changing the motion of an object that has more mass.